Before you do any kind of data science, you obviously have to get the data to be able to analyze it, visualize it, narrate it, deploy it. And what we're going to cover in this module is how do you get the data. There are three ways you can get the data. The first is you can download the data. Either somebody gives you the data and says download it from here, or you are asked to download it from the internet because it's a public data source, but that's the first way you download the data. The second way is you can query it from somewhere. It may be on a database, it may be available through an API, it may be available through a library, but these are ways in which you can selectively query parts of the data and stitch it together. The third way is you have to scrape it. It's not directly available in a convenient form that you can query or download, but it is in fact on a web page. It's available on a PDF file. It's available in a Word document. It's available on an Excel file. It's kind of structured, but you will have to figure out that structure and extract it from there. In this module, we will be looking at the tools that will help you either download from a data source or query from an API or from a database or from a library, and finally, how you can scrape from different sources. Let's start with how you can download data. The most obvious source is you search on Google. Let's say you want movie data. So just say movie data download. And that might give you a few sources, like Kaggle seems to have a movie data set, and data.world has a list of movie data sets. The Internet Movie Database has a series of data sets. So you could go through each one of these. So this one seems to have credit information and it's about 189 MB. Data.world has links to several other data sources, and there is the Internet Movie Database dataset. This, incidentally, is something I know to be one of the most comprehensive movie datasets, perhaps the most comprehensive movie dataset that has details about every single title and further information about each of these titles, the crew of every one of these, and so on. And it's something that you can just directly download from the AWS site. It's available as a gzipped file that's a TSV. TSV stands for tab separated value. So that's like comma separated value, but separated by tabs. To give you a feel for what one of these files looks like, this is what names.basics.tsv looks like. It has a name constant, basically the primary ID of the actor or the director or whoever, the primary name, which in this case is Fred Astaire, the year of birth 1899, the death year 1987, what their profession is, primarily soundtrack. So Fred Astaire is a singer and an actor and other things. And Fred Astaire is known for these titles, and these titles are described in title.basics.tsv. Now, this kind of information is your starting point to create any kind of analysis and any kind of visual representation. So, for example, one of the things that I'd put together with this IMDb data was a personal movie watching or movie recommendation engine for me. I looked at it. This is at grammarly.com/imdb, and you're welcome to explore it. This shows the movies by rating. So the higher rated movies are on top, and by popularity, the number of votes that they got. So movies with just 10,000 votes or less versus movies with 2 million votes and above. So if I look at each of these marks, they represent a set of movies with a certain rating and a certain number of votes or a vote range. On the top right are the movies that are both popular and highly rated. So if I look at that list, that contains The Shawshank Redemption, Dark Knight, Inception, blah, 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 pretty much all of which I've seen. And I can use this to figure out now what are the other slightly less popular movies that I need to watch. So again, most of these I have seen, but the Intouchables is one of those that I'm yet to see. So that's a pretty strong recommendation for me to watch next. Or if I'm not quite in the mood, then I could ask the question, are there movies that are really popular despite them not having, movies that are more popular than their rating suggests. So we have here a few movies that have a relatively let's move this a little bit. Okay, a couple of movies that have fairly high number of votes, but a really terrible rating. And Radhe is one of those, fairly popular. For those who may not know, that Radhe is Salman Khan starrer. which has a 1.9 rating, which is like among the lowest that anyone ever gives on IMDb, but it's pretty popular. This can tell a number of other stories as well. So I've been using this to look at the history of animation movies. So if you filter by type movie and genre animation and look at the story of animation across decades, in the 1930s, there was pretty much only Snow White and the Seven Dwarfs, Disney's first entry into animation. But then in 1940s, they made four movies: Pinocchio, Bambi, Dumbo, Fantasia. But other studios also started coming in, but they weren't doing such a good job of movie writing. And Disney was clearly a cut above the rest. That continued in the 1950s as well. And in 1960s, though the other movies started catching up, movies were kind of Disney only. In the 1970s, there seems to have been, firstly, a slight deterioration in Disney quality and an overall mix. You can't really tell which are the Disney movies and non Disney movies, and this was easily the worst period for cartoons in general. 1980s, we have a slight resurrection, but this is not Disney driven. This is, in fact, Ghibli Studios from Japan. So, My Neighbor Totoro or Akira, Nausicaa, Castle in the Sky, many of these are classic Japanese anime films and is the birth of anime in cartooning. 1990s, however, represents the golden age of Disney and Pixar, with Lion King coming in from the traditional Disney studios and Toy Story breaking the mold with computer animated cartooning. And that partnership continued in the 2000s with several hugely popular and highly critically rated movies like Wall-E, Finding Nemo, etc. 2010s, that trend continues, and now you can see that it's pretty much mainstream movies. Animation movies are pretty much really popular, and in the 2020s, Soul is one of those that has really broken through as one of the better films. Now you'll notice that all we are doing is, having downloaded the data, just applying some three simple filters: animation, movie, changing the decade, and showing this on a scatter plot of rating versus number of votes. It's that simple, but that gives you a sense of the power of bulk data. If you're able to download data at one shot, then the kinds of things that you can do are really interesting. But what if you can't download that data? What if there is no such data and you have to figure it out through other means? Well, one of our clients, a media company, was doing exactly that. They wanted to understand what the public is interested in. So they hired a marketing agency to do surveys. They talked to almost a few thousand people and come back with what is it that most of India is curious about. Now, these surveys cost a lot of money. Our client said they were paying something in the order of like 30% months worth of salary for these kinds of market research surveys. So their question was, is there a way by which we could actually get this information without so much effort? Well, let's do one thing. Let's go to Google and search for how to. And you find that Google automatically provides a series of suggestions: how to use CDC voucher, how to screenshot on Windows, how to wrap a gift, how to screenshot on Mac, recall, email, and Outlook, and so on. Now, this effectively is based on what people are searching for in recent times. Now, I happen to be in Singapore at the moment while I'm recording this video, so these are results for Singapore. But in a given region, you can find out what is most popular with the public, what is it that the public wants to know, without really having to do that much research, because Google is already doing this research for us. Is it possible for us to query this information? Now, it's going to be pretty hard for us to bulk download it, but can we query it and get it in pieces? Well, it turns out that this is an undocumented API in Google. So one part of it is that there is an API, which is good news, because that means we can run the same query and get that information. But the bad part is it's undocumented, but we can figure it out. So let's press F12 here, go to the network inspector and search for how to put another space. And it runs this query. It sends a request to google.com/complete/search with a series of parameters. If you look at the parameters, there's a Q, which is how to, a CP, I don't know what that is, a client GWS Viz, I don't know what that is, and so on. But what I can do is copy this URL and see if I can run a different query. So instead of how to, let me try where and see what results I get. So it downloads a certain file, which looks like this. Let's see what it returns. It returns an array of arrays where the entry says where to use CDC vouchers, where to go in Singapore, where is Santa, where to change token, and so on. So let's see if that's actually correct. Let's search for where. And yeah, where to use CDC vouchers, where to go in Singapore, where is Santa. These are exactly the results that we get. So, which means that we can take a URL like what we just saw and change the query parameter from where to any other string and see what happens. So we actually did that. And at grammarly.com/search, there's a page that shows when people type how to in different countries like India, UK, US, Singapore, what are the results? So in India, for example, how to delete Instagram account, how to calculate percentage, how to deactivate Instagram account. These are the top trending queries at the moment. So that's what India wants to know, how to delete or get out of Instagram. The UK and the US want to know how to screenshot on the Mac. The UK wants to know how to reduce weight fast. They also want to learn how to make pancakes, which is a bit of a contradiction. But both the US and the UK want to know how to get rid of fruit flies. So that looks like a perennial problem. Or if you ask the question, how do I? The UK is curious about how to get a PCR test, but the US is more interested in taking a screenshot. So you can see that there's more of a COVID problem in the UK than in the US. So if you were a UK publication, you'd be writing more about COVID, whereas you'd probably be writing more about technology for a US publication. Now, what we were doing here was effectively using an API that Google provides. This happens to be undocumented, and querying for information and assembling it together to get bulk data, on top of which you can do further analysis. The third way of getting data is when both these methods fail. There's no ready download. It's not like there's a clean API that you can call that will give you structured data, but the information is either, say, in a PDF file or in a web page or in a Word document, Excel document. It's kind of structured, but you have to go into it, pull the right pieces of information and assemble it. That's hard, but sometimes it's the only way and sometimes it's worth doing, and that's what scraping is about. That's the third thing that you learn in this module in terms of ways of getting information. How does one scrape and where might we use it? So one of the things I was curious about is who's the fastest one-day international cricketer in terms of strike rate. So if you look at, for example, the list of all players on howstat.com, so this has, let's say, all the players whose name starts with C, so Caddick, Cairns, and so on. Let's pick one of these, Campbell, and look at Campbell's performance in one-day internationals. So Campbell has a strike rate of 66.19. That is in terms of out of every 100 balls that he's played, he's scored on average 66. Now, I'm curious about who has a high scoring rate. But of course, I'm also interested in seeing how much they've scored overall. So Campbell scored 5,000 runs in one-day internationals. That's sizable. If somebody just played one match, hit a six and got out, they'd have a scoring rate of 300 because 2 balls, 6 runs. But that doesn't really count, right? So we've also got to look at how substantial their score is. Now, I could compare Campbell with another player. Let's pick Chanderpaul. And Shivnarayan Chanderpaul has scored 8,000 runs at a strike rate of 70. So he's a slightly faster scorer than Campbell, who's been scoring only at 66. Now, this information needs to be compiled across all of these pages, and that's quite a task, but that's exactly where scraping comes in. What you see here on the right is a scraper for Howstat. It uses the Beautiful Soup Python library to scrape the data, and you'll be studying this in some more detail in one of the examples in this module. But what we do here is effectively start with the player list page, which is what you see on the left. Now you can see that it says group is equal to C. That basically means it's showing all players whose name starts with the letter C. And I could change that to group is equal to D. And once it reloads, it's showing players like Da Costa, Da Silva, Dahani, Dahia, and so on. Players whose name starts with D, and this gives me a complete list. So this is like an entry point into getting the information on a player-to-player basis. So what the scraper does is goes through all of the letters from A to Z and opens the pages with the player list. And then within that, it specifically looks for any link which points to player overview summary.asp question mark player ID is equal to something. So this 2247 is the HIA's player ID. And if you click on this, you'll go to the next page, which has the details of their performance. So it searches for player overview summary question mark player ID is equal to any number and gets all of these numbers and the whole links. And then it goes into the respective pages that has their ODI summary, and from there gets information from the tables by looking at all of the cells and concatenating all of those and then putting them into a single CSV file. So this is kind of how scraping works. And what can one do with this kind of scraping? Well, in my case, I was curious to see who the top one-day international players were, strike rate-wise. This is data that was pulled in 2011, so it's fairly outdated. But you can see that Tendulkar is one of the larger players, right? In terms of number of runs. The size of the box represents the total number of runs. So Tendulkar scored the most number of runs at that point with 18,000, followed by Ganguly at 11,000, followed by Dravid at 10,800, and so on. And the color represents the speed. So Sehwag scoring really fast at a strike rate of 105. Kapil Dev is a reasonably fast scorer at 96. Yusuf Pathan hasn't really scored much, but still is pretty fast at 115. But in contrast, Gavaskar is not a very fast scorer. 62.9 strike rate. Ravi Shastri is even slower. Mohinder Amarnath is even slower with 50, what was it? Oh, okay, it's a little hard to. Mohinder Amarnath at 58, and so on. Now, you'll find that the older players are relatively slower. The modern players are generally faster. There's been a slight creep in strike rates over time. And then you can drill down and look at individual innings, every single one of Tendulkar's innings. So this was his 200 at against South Africa in 2010. This was a much slower innings where he scored 100 at only a 72 strike rate. And here's another relatively slow innings where he scored at a strike rate of 32 and got to only 17 runs, and so on. Now, you can expand this and get the full list of every single one-day international ever played until that point by anyone in India, and then start looking for their performance against specific countries, like who's scoring really well against Pakistan. It turns out that Sehwag's consistently scoring well against Pakistan, and Dhoni's got a reasonably good performance. Or who does well in Sharjah. So Kohli, Dhoni have badly played in Sharjah. Yuvraj's got a really poor performance in Sharjah. It's mostly small number of runs at a slow pace, but Tendulkar's doing really well in Sharjah, and so on. Now, this becomes possible because what we are doing is extracting the information page by page from a site like HowStat and pulling that out to be able to create the kind of a data set that we want to be able to analyze. So these are the things you'll learn in this module about getting the data. Number one, how do you find data that you can download? Number two, how do you query data if it's in the form of, for example, an API? We'll be looking at the Nominatim API, which will help you convert addresses to latitudes and longitudes. For example, the BBC Weather API, which will give you the weather for a particular location. And we'll also look at how you can scrape data from web pages, how you can scrape data from PDF files, and so on, to be able to collect all of the data that's required for further analysis